Okay, so now taking a look at some specific examples of dilations. For example, problems 1 through 3 says find the scale factor of the dilation and then tell whether the dilation is a reduction or an enlargement. So on number 1, here's what you have to take a look at. Here's CP. C is the center of dilation. P is actually the pre-image. And then P prime, this is the image. So the original or the pre-image, C to P, that's 4 units in length. And then C to P prime. If this is 2 right here, this also has to be 2, which means this is 2, this is 4, this is 2. But C to P prime is 2. So it's definitely a reduction from 4 to 2. And then scale factor, I would think it'd be pretty easy to find. CP prime to CP, 2 to 4, definitely don't leave it like that. 1/2, I mean, technically you could write 0.5 as well. That would be the scale factor. All right, and then on the next example, here's the pre-image P, C to P, that's 20 units in length, and then C to P prime, 25. Okay, again, I think it should be fairly obvious since this is the image and this is the pre-image. The image is larger than the pre-image. It's an example of an enlargement. And then to figure out the scale factor, K, I could do something similar to what we did before. You definitely should know that K is going to be more than 1. So if you're not sure, like what should go in the numerator, what should go in the denominator, larger number goes in the numerator. Or it's the image over the pre-image. 25 over 20. Don't leave the scale factor like this. Your algebra teacher should have said last year, and probably all your other math teachers, anytime you have a fraction, you always want to put a fraction in lowest terms. So I'll simplify this by dividing both the numerator and denominator by 5, and then 5/4 would be the scale factor. Or, I mean, you could write 1.2 as well. All right, and then a couple more examples here. So the example on number 5 is similar to one we did earlier. I really want to find the coordinates of the image P prime, Q prime, R prime, S prime with the center of dilation as the origin. And then here's the scale factor, 1/5. So instead of graphing all those points first and then trying to figure out the coordinates of the image using the graph, I could use the scale factor and then just multiply the scale factor K by the X and Y coordinates. So P prime would be -10 times 1/5. So that's -2 for the X coordinate. And then 0 times 1/5, 0. Coordinates of Q prime, just repeat the process. -5 times 1/5, -1. 0 times 1/5, 0. R prime, 0 times 1/5 is 0. 5 times 1/5, 1. Lastly, S prime. -5 times 1/5, -1. 5 times 1/5, 1. And then just to save a little bit of time, I'm not going to graph those, but you should be able to graph those as well. All right, and then on number 6 and 7, it says find the coordinates of the image of the polygon after a dilation with a scale factor of K. Okay, all you need to do is find the coordinates of the image, so it'd be almost identical to what we did earlier. On number 6, the scale factor is -6. We kind of didn't talk about that. That just means that the image is going to be on the opposite side as if or as opposed to a positive scale factor. But you could use the same process as far as if the center of dilation is not given, that implies that the center of dilation should be the origin or 0, 0. So since the center of dilation is 0, 0, then I can just multiply the scale factor K by the X and Y coordinates. So A prime would be -3 times -6, +18, 1 times -6, -6. And then B prime, -4 times -6, 24, -1 times -6, +6. C prime, -2 times -6, +12, excuse me, and then -1 times -6, +6. Doesn't even say to graph that. So those would be the coordinates of the image. Again, make sure that you're using the correct notation, which is prime notation.